Welcome. So I've got a webcam coming. Hopefully it'll be getting here sometime today, but at least that's what Amazon says. However, I wanted to get this lesson out to you guys as soon as possible, so I'm just going to go ahead and record from the webcam on the computer, which is an annoying place down at the bottom. But anyway, let's dive right in. We're going to be talking today about functions. So this is the topic of the next unit, Unit 1. It's all going to be about functions and the things we started off the year with, linear equations and quadratic equations. Now those are just kinds of functions, and basically everything else we're going to talk about this year, except for a chunk of trigonometry, is going to be about functions. So this is the general part at the start where we lay down kind of what a function is and what is what kinds of information can we learn about functions, and some generalities that you can do with functions that will apply no matter what it is. So if it's a quadratic function or an exponential or a logarithm or any of these other functions, all of these principles will apply. So it's kind of important that we lay this groundwork down now and then see how it works in different contexts throughout the first semester. Okay, so let's dive right in. So what is a function? You've probably heard this word before in Algebra 2, possibly Algebra 1 as well. We'll just go forth with what the definition is. So a function is a relation, meaning it's taking it's kind of giving you a rule or an association between two things, okay? So the one thing is called an input. That's kind of what you control. That's your oftentimes called the independent variable. That's what you decide what to put in, and the set of all these inputs is called the domain. So you have a bunch of numbers or whatever that you want to plug into a function, and then it's going to give you an answer, and the answers are called outputs, and they're going to come from, or all those answers, the set of all of them is called the range. So that's where they're all going to come from, is some other set called the range. And so here's kind of a picture to describe what we have going on. You can think of it like a machine where you're plugging some x in, so the x goes into this function machine. So your x would be an input, that's x, and all the possible inputs, that's the domain. So maybe you've got lots and lots of different inputs, and so each one is coming from the domain. And then you've got your function machine, which does something to x, whatever it does, there's a rule, and that rule is, usually given to you with an equation. It says, like, do this to the input. So you've got your function rule or relation, and then it's going to give you an answer, and that answer is the output, and it's usually called f of x. So the output is f of x, pronounced f of x. Let me write it down over here. F parentheses x is pronounced f of x. Okay, so that's how we say that, not f times x. This is not a multiplication. It is a different notation. So sometimes it's confusing for students initially because they're used to thinking, oh, this means times, parentheses, but this is not a multiplication. This is a notation to say what the input is, which is x. So this is f of x, that's how you pronounce it. And then, again, all of the possible outputs you're going to get are called the range. So that's all the things that the function can give you as answers. And then last piece, so you've got your domain, which is all the things you're plugging in. You've got your range, which is all the things that you're going to get out. And you have your rule, which tells you how to go from the domain to the range, how to get your input to an output. And this is important, is that the inputs, let me use a different color. So let's use purple. Each input gets exactly one output. So it's not a function when an input goes to two places. So we'll see some examples of this in a little bit when we say what's a function, what's not a function. So it has to go exactly to one place. Another thing to note, just these names, functions are typically given a name like f, g, or h. F because f is the first letter of function, and G because that's the next letter in the alphabet after F. So very creative. And then inputs are typically called X, but they don't have to be. You can use any letter. So maybe you would see a function like, let's use F, oops, let's go back. F of, T. Maybe T is our function variable. And so, that's perfectly fine. T would be oftentimes used when you're describing time, but we use f of x a lot in math. Okay, so let's talk about each of those key pieces. We had relation, domain, and range. So let's talk about the relation first. So relation is a rule. It's a way to associate an input with an output, okay? So here's some example relations. So that's a relation, right? This says take a number. So this means multiply the input by 3. Input by 3. And then add 1. Then add 1. So we know how to get to the answer, right? We take our input, we multiply it by 3, and then we add 1. So here's some example relations or evaluations we could do. We could say like f of 2, what would that equal? You multiply the input by 3, and then you add 1 to it. So let's try that. This is going to be 3 times 2 plus 1, which is 7, right? So you can find an answer. And this relates the number 2 from the domain with the number 7 in the range. So 2 is coming from our domain. Let's use colors here. I was using red and green earlier. 2 is our domain, and 7 is in the range. Sorry, 2 is not the domain. 2 is in the domain, and 7 is in the range. Here would be another relation. So let's see what would be associated here now. So let's try, G of 4. So this is equal to, whoops, backtrack. G of 4 is equal to plus or minus root 4. And that's giving you 2 answers. So we have 2 and negative 2. Those 2 answers right here. So what this is associating is the number 4 in the domain with 2 and negative 2 in the range. So you're seeing that 4 from the inputs is going to 2 and negative 2. So it's going to 2 places. Another potential relation is if you say you want to plug in a polygon. So this is without a number. This is a different way of describing functions. What if you plug a polygon in? You say, okay, these are examples of polygons. And the output is how many vertices that polygon is. So let's take a look at a potential example. What if you do h of square? Ooh, weird. Okay, what's h of square? Well, you count the number of vertices. Those are the corners, right? The points on the edge. And so what would h of square be? Well, I count 1, 2, 3, 4 vertices. So that's 4, right? So that's another relation, which you start your domain as all the polygons, and your range, what you're going to, are just whole numbers, right? Okay. So let's look at examples of relations that aren't functions. And so the answer to this is no, that there are relations that are not functions. If you have more than one answer for a particular input, then it's not a function, okay? So some examples. From earlier, this relation is not a function. So let's say, we tried to evaluate f of 4 as we did earlier. And we got two answers, 2 or minus 2. And so because we don't have exactly one answer, it's not a function. It's a relation, but it's not a function. So that in order for this to become a function, we'd have to choose one of these two answers. We'd have to choose either the positive or the negative answer. And we can't have two answers. We need just one answer. Okay, here would be another example of a relation that's not a function. So if you plug a name in, and then the output is the person that has that name. Now, I don't know if you've noticed, but you know, your login information, for example, when you have the 001 or 002, that means that there's other people with exactly your first name and last name that have gone to Franklin High School. There are lots of David Ackermans out there in the world. If you do a Google search, you're probably not going to find me. You'll find other people. And so, you know, if you plug in G of David, there's no one answer. You know, there's many, many people with that name. So this is not a function. You know, too many people. And so that wouldn't work. Here's another example of something that's not a function. It's a relation though. So you plug an area in. So your input is an area. For example, you have an area that's 10. So you want 10 units squared. And then the answer, the output is a polygon with that area. Well, we can just like come up with many polygons that are going to have an area of 10. For example, I could draw a rectangle that's a 5 by 2 rectangle, and that would be an answer. Or I could draw a rectangle, or let's try it with the triangle. I could draw a triangle that has a 4 by 10 side dimensions, right? A right triangle. You remember how to find the area of that. You multiply 4 by, sorry, this needs to be 2. This is what happens when you come up with these examples on the spot, is they don't always work. So a 2 by 10 right triangle, if you multiply 2 times 10, you get 20, divide by 2, and that would be 10. So these have the same area, and they're not the same answer, right? So you have multiple answers, right? There's many, many answers for this. So that's not, it's a relation where you have an area, and you have something that an object you're relating it to, but it's not a function. Okay. So let's talk more about domain and range. For the most part, just as an aside, most of what we'll be talking about are actually functions in this class. So I just want you to think about, okay, how, if I plug in numbers, can I get multiple answers? And if you can't, if there's just one answer, then you're good. You're good to go. All right. So let's talk about the domain, and that's all the possible inputs. And another word that people use for the inputs is arguments. So I might use input or argument interchangeably. What's the function's argument? That's what you plug in. So if you don't specify it, you don't say what the domain is, you're going to assume that it's as large as it can be for that function. All right? So let's look at a couple of examples. So let's have the function that's the square root of x, okay? So this says take the square root of your input. And if you think about taking square roots, you're not allowed to take the square root of a -1 or negative numbers, right? And so in this case, your domain is going to be everything that's 0 or larger, right? So x has to be 0, because you can square root 0, that's fine, you get 0 as the answer, or things that are bigger than that. Okay, so you can take the square root of 1, you can take the square root of 2, square root of 3, square root of pi, any of those numbers are fine, they just have to be larger than or equal to 0. What about a linear function? What's the domain of that? Well, the domain for a linear function is let's put a colon there. The domain of a linear function is going to be all the things that you can plug into it. There's no restriction on what you can plug in. You can plug in negative 100, you can plug in 100, you can plug in 1,000,000, 0. All these numbers are fine to evaluate. So our domain is all real numbers, and we can use the R with a line in it, a second line in it, to describe all real numbers. Another way to talk about this is you could say negative infinity less than x less than infinity. Those are equivalent ways to describe the domain. What about 2 to the x? You may have seen a function like this before. It's an exponential function. If you tried to plug in negative numbers, then it still works. You can still do 2 to the negative 100. In fact, let's just do that over here. Maybe you remember this, maybe you don't. 2 to the negative 100 is equal to 1 divided by 2 to the 100. So that's perfectly valid to evaluate that number. It's a very tiny, tiny, tiny number. It's very close to 0, but it's a number. And you can plug in positive numbers, you can plug in 0. And so again, this is a function that has a domain of all real numbers. So I'll just write R with the big R with a line in it for short. Okay, so how did I figure out those domains? So these were kind of the strategies I always use for determining a domain of a function. I'm going to try to plug in large negative numbers, you know, something like negative 10,000 or negative 1,000,000. I'm going to try to plug 0 in. I'm going to try to plug large positive numbers in, like 10,000, 1,000,000, etc., and see if any problems arise when I'm doing these evaluations. I usually don't fully evaluate the function, meaning like find the actual answer. I just checked in my head, oh, does it make sense for me to do this, to evaluate this function for this number? Or does it not make sense? So let's look at an example of doing this. So when you've got square roots, you know that you can't take square roots of negative numbers. So you know that if your inside of the root is 0, then you can kind of decide, well, what is going to give me a negative number and what's going to give me a positive number. So if we aim for 0, and then we can kind of decide, all right, do I need to go smaller than this or larger than this? So let's do this in an example. So we've got a function, square root of 4 minus 2x, and we want to evaluate it, find its domain. So what makes sense for numbers to plug into this? So let's go ahead and try setting the inside to 0. I mean, first and foremost, let's try the strategy that we have above, which is to input large negatives, 0, and large positives. So if we plug a large negative number in, square root of 4 minus 2 times negative 100, for example, then let's see if this makes sense. Does this make sense to evaluate? So what is 4 minus 2 times negative 100? That's going to be negative 200. So this is really 4 plus 200, right? So without actually evaluating this, we can kind of pause here and say, hey, you know, it does make sense for large negative numbers. Like I can plug in negative 100, negative 1,000, and this will still work. If I tried it with a large positive number, so let's go ahead and swap it around. So if I tried it with a large positive number instead, then you're going to find 4 times negative 2 times 100, and then this is 4 minus, this becomes a minus sign, and 4 minus 200, square root of that, that's going to be a problem because we've got a negative inside the root. So it looks like large positive numbers won't work. So these will work, but these guys won't. So let's try to figure out, though, exactly what the domain is. But this helps us think about it a little bit. So I want the inside to be 0, and then I can decide, all right, do I want to go less than this number or more than this number? And if I go more than this number, then what's going to happen? And if I go less than this number, then what's going to happen? So let's test this out. Okay, so 4 take away 2x. If I set that equal to 0 and then solve this, I'm going to get 4 equals 2x. So that says x is equal to 2, right? Divide both sides by 2. So now we have to decide, do I want numbers that are less than 2 or more than 2? Do I want the left side of the number line? You know, here's 2. Do I want to go this direction or do I want to go that direction? So which way are we going? And so hopefully you recognize that you want to go to the left, because remember, we can plug large negative numbers in, right? So we can plug negative 10,000, we could plug negative 100 in. So we want numbers that are smaller than 2. If we tried to plug in 3, you'll see it won't work, right? So if you tried to plug in 3, so we don't want those. But let's just test, you know, what happens if we plug f of 3 in, and then we're going to get square root of 4 minus 6. And that's root negative 2. So that's no good, right? So that means we want all the numbers that are 2 and smaller. So here's our domain. Our domain would be, domain is going to be x less than or equal to 2, right? So all the numbers that are 2 and smaller. Always remember, so this is like a fundamental rule, and we're not going to see too many things more than this, but always remember you can't take a square root of a negative. And another thing to remember too is you're not going to be able to divide by 0. So if you've got a fraction and you find, you know, that you might be dividing by 0, watch out for that. That's not going to be allowed for your domain. Okay, so I want to introduce another notation for describing these domains and ranges. Well, we haven't talked about range yet, but we'll use it for when we get there. And it's called interval notation, and it's just a way to describe sets of numbers. So for all these examples that I'm going to show you in a minute, you want to assume that A and B are real numbers and that A is smaller than B. So here would be an example. So here's a couple of ways to relate interval notation with inequalities, which you have seen last year. So when you use parentheses, that's the same as a strictly less than symbol. So A comma B in parentheses is the same as all the numbers that are between A and B and not including. So if we've got a number line here, the way you would describe that on number line is, let's use blue, open circle at A, an open circle at B, and then you shade in everything between those numbers, okay? So that would be one way of using interval notation if you've got all the numbers between A and B not including. When you use square brackets like that, then that just means include our endpoints. So the difference is we fill in these circles. Let me fill it in. You fill in the circles, and then you shade in everything in between. So it's a circle filled in, if it will let me. Okay, there we go. So that's the only difference between brackets and parentheses. And what if you've got an inequality where it goes on forever? So, for example, all the things that are less than or equal to some number, well then you'll use negative infinity as your left side of the interval and B, or whatever value you're going up to, as the right side. And remember, the bracket means or equal to. So this would be all the stuff from B including B, and then everything to the left. And if you have parentheses, then you're going to have everything that is strictly to one side of that number. So parentheses A, infinity, is going to be all the stuff that's larger than A, strictly larger than. So you would use an open circle then, and you would go to the right. So you fill in everything that way. Okay? So one thing to note is that if infinity is an endpoint, so if you've got all the numbers less than something, so that goes on forever, or all the numbers greater than something and that goes on forever the other way, then you want to use parentheses or at where the infinity is instead of brackets. Okay, so just remember infinity and parentheses go together. Numbers can either be with a bracket or with a parentheses. Okay, let's use this notation and talk about another thing you can do with domains and functions is that you can specify the domain, so you can narrow the domain down to a smaller set than it would be if you didn't specify it. So for example, the square root function, if you take that square root and you say, instead of looking at all the possible numbers, I just want to look at the numbers between 4 and 9, including 4 and 9. So that's going to give you a function, and you're not using all the possible numbers. You're just looking at stuff from 4, including to 9 as your inputs. So, for example, with this definition for f, if I want to evaluate f of, for example, 4, that's fine. I get the number 2, right? Because the square root of 4 is 2. And if I try to evaluate f of 1, that's actually undefined. It has no answer because it's not, 1 is not in our domain. Even though you can take the square root of 1 for our function f here, f of 1 doesn't make sense, okay, because of that domain. You could take a linear function and say, all right, I want my linear function to go from negative infinity to 0, including 0. So that would be all the stuff. This is the same as x less than or equal to 0. So that's all the things from 0 to the left. So that would be a perfectly fine function. You could also specify the function we had earlier for h of x. We get to say we want to plug only numbers from 1 to infinity. So we only want numbers that are 1 and larger. So this would be 1 less than or equal to x. So you can plug 10 in, you could plug 100 in, but you're not allowed to plug in 0 or 0.5, etc., etc. Okay, so we've talked about the rule or relation, and which kinds of relations are rules and which kinds are, which kinds of relations are functions and which aren't. We've talked about the domain, which is all the things that you can plug into the function. We've also talked about how you can make the domain smaller if you want to by specifying what you want for your domain. And now let's talk about the range, which is what are the answers you can get out from the function. So the range is a set of all the outputs, and I'll also use the word value. So output and value, those are interchangeable. Values are the answers or the outputs that a function can produce, and this is called the range. One really important thing is that the range depends on the domain and the rule. So what domain you specify and what the rule is for evaluating, okay? So if you shrink your domain down, then you're going to be affecting the range. Typically, you always figure out what the range is from the domain, and you control the domain to be what you want it to be. Okay, so here's some examples for figuring out, or for ranges of things that we've looked at, those functions from earlier. So the square root of x, this function's range is going to be, the range of root x is going to be, using our interval notation now, I'm going to use that interval notation, is from 0 to infinity. So it's going to give you positive numbers and 0, so all the things that are non-negative. And if you think about why this is the case, we know you can get the number 0, right? You know you can get this number, and you can get 0 because, so if you were to try to figure out what does x need to be, for if you were to plug get 0 as your answer, you can see that if I plug a 0 in here, if I plug 0 in, I take the square root, I get 0 as an answer. So we do get this number 0. And then if you were to plug in larger and larger numbers for x, you'll get larger and larger outputs. That's a check mark. You'll get larger and larger outputs, and there's no limit to the size of the output that you're going to get. So that's why our range is going to be from 0, including to infinity. And then a linear function, what's the range for that? Well, it's a little bit tricky. If m, that slope, is not 0, then it's all real numbers. You're going to get all real numbers if the slope is not 0. And I want you to think about it a little bit. What are the answers going to be if the slope is 0? So if m is 0, what will the answers be? What are you going to get for your answers? So take a minute and think about it. So hopefully you came up with that the range would be just the number b. So range is just going to be b. I'll put b in little squiggly braces. And that's if the slope is 0, right? You're only going to get b as your answer because no matter what x is, then this would be 0 plus b. So you always get b. All right. So that'd be a linear function. Now here's a tricky one. 2 to the x. 2 to the x, what would that be? What would your range be? So I'll tell you what the range is, and we'll see why it's that. So the range for 2 to the x is 0, but not including, up to infinity. So it's always going to be positive, and you can't get 0. You're not allowed to get 0 no matter what. So how do we determine that range? How do you determine that range for 2 to the x? Well, if you think about 2 to the x, you think about that number. What happens if you plug in, say, 2 to the negative 100? And so if you evaluate this with your calculator, it may not even tell you the answer. It might say, I can't find it, or it's 0. It's not actually 0. It's 1 over 2 to the 100. It's this number right here, 1 over 2 to the 100. And this is 1 over an incredibly large, right? 1 over big. I'm going to write big number. 1 over a big number. And that's very, 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 very tiny. That's very nearly 0, but not. It's slightly more than 0. So this is just a little bit more than 0. It's greater than 0, no matter what. And so you're never going to get 0. You could keep plugging in larger negative numbers. Keep going more negative. You'll always be a little bit larger than 0. So that's why we have only numbers that are larger than 0 here as your range. And then, for example, if you wanted to look at what's 2 to the 100, that answer, well, that's very large and positive. So this is a large, this is equal. This just equals big. 2 to the 100 is big. It's much larger than 0. And so it continues, it will grow forever. It will be as large as you want it to be. So that would be our range for 2 to the x. Okay, so some strategies for determining the range. Same idea for domain. Look at what happens when you plug large negative numbers in. What happens when you plug in 0. What happens when you plug in large positive numbers. Okay, so get a feel for the answers. But actually evaluate. So you have to take it all the way to what would the answer be if you plug these numbers in. Okay. And then another thing to be mindful of, if your domain is not all real numbers, then look at what the function will be at the endpoints. So what would the function's value be, when you're plugging in that number, not infinity, right? So check the endpoints of the interval then. We'll get to this a little bit later. You also can look at the function's graph. That's a really good way to get a visual sense of what the range is and a visual sense of what the domain is. And we'll talk more about this in the next lesson. And then remember specific things about, there's different cases, different kinds of functions. remember, like a function like quadratics, they have a range that depends on the vertex. So wherever your vertex is located, you're not going to get answers that are either below, if the parabola is up, that number, and you're not going to get answers that are above, if your parabola is facing downwards, that number. So the min and the max are linked to the range for parabolas. Okay, I think that's probably enough for this lesson. We'll get some practice with domain and range in class tomorrow or on Monday, and then we'll do some more examples involving graphs the next day. So hopefully you learned a little bit about functions, domain, range, and how do you determine if a rule makes a function or doesn't make a function.